Hi everyone. I wanted to get this recording done to help get you started with the VEXIQ for this season. There are a number of things which I've learned as I've built the robot, and I've worked with a few schools, been to a few events and so on. We're getting into the season here. We're getting lots of people interested in getting back going. So I hope this will be useful for a few folk. I'll keep this as short as possible, and we can follow up with any questions to the email address and so on afterwards should you have any questions. Okay, this is going to primarily focus on the build of the robot very briefly, and then I'll focus a little bit on the programming, because there are definitely some programming elements that we want to make you aware of. Okay, so I'll advance here. So every year there's a hero bot associated with the game. So this year the hero bot is called Fling. There's lots of elements in the new game. So throwing balls, hanging, pushing balls, clearing spaces. So this robot is the robot that's been determined that will allow you to throw a ball. It allows you to hang. It kind of allows you to push balls around. This robot's not going to win you a competition or, as it stands, or certainly won't win the Worlds. But it's a great starting point and gets the kids thinking about what they can do to this robot to improve it. It is the most complex build-based or hero bot ever, in my opinion. There's multiple parts to this which makes it complex, like the catapult mechanism. There's an intake system. There's a bumper switch that needs to be programmed as part of that catapult, and there's a drive chain, or in this case it's a belt, but there's a whole driving mechanism in terms of that intake. In most years, the robot controller doesn't have to be pre-programmed. You can just use the default driving control from the brain. In this case, it needs to be programmed in order to have the full use of all the components on this build. And I'll cover some of that shortly. There's a few things that I wanted to bring up as part of the building of the robot. This isn't going to be a webinar focusing on building, but just some things that I learned as I was building it. First thing is 2 versions of the build instructions. There are now 2 different, VEXIQ have launched a new brain. It's the Gen 2 brain. And as part of that, they've also launched new kits. So most of you will probably have the Gen 1 kit and the Gen 1 brain. So pick the correct version of the build instructions for Fling. The QR code on screen here is specifically to take you to all the build instructions, but select the correct one for you. There's a fefew things as I built the robot, I kind of figured out, and I actually have a version of Fling. Think of this as Joe's version of Fling, because it has got a few modifications that you just might want to be aware of when you're building it. So this is the catapult, so it will go down and then spring back up using the rubber bands at the back. And what I found a few times is the catapult does get jammed in a few places. So there's lots of bars which give this stability. So it's important that when the kids are building this, that they keep the stability in, but also it can get jammed in a few of these spots. There's also these little black bars. You probably can't see this here, but there's some black bars on the big cogs here. And this is what actually enables the arm to go down. They can actually get caught on the way back up. So I've added a few spaces in here. I think my problem was I probably didn't build this probably right the first time, but I've added a few spaces there, and that solves the problem of this getting caught on the way down. The other thing that I've noticed is sometimes this bumper can get a little loose as the arm comes down and hits the bumper. The bumper can get loose, which will then mean that the bumper's not in the right position. It's also sometimes could happen if you have the wrong angle for the bumper. Just here. Okay, this robot is probably one of the widest robots. This robot I have in front of you here will not pass inspection because it is too wide, because I have the brain in a different position. That was just me experimenting. But yeah, just bear in mind that making sure the wheels are in, it's at its limit in terms of this width size. The length is shorter, and you can just obviously adjust that if they customize it. Also, having the motor, the instructions are quite difficult to see actually when you place the motor for the catapult. I actually had it in the wrong place. Let me go back a step. I actually had it plugged into here. And what I was noticing was my arms, it was functioning. It was going down a lot quicker, but sometimes didn't have enough power to go down. That's because I was at a high gear or low gear, a high gear ratio, and which was one for one. And I wasn't benefiting from the gearing that placing it in the right place gives you, which gives you more torque. And they're a bit slower, but at least you have more power to bring the arm down. So just bear that in mind as you're building your robot, just to make sure you place your motors in the right place. So that's just the things I noticed when I was building it. The other thing that's quite apparent, and some of you probably had this issue with batteries. This is the main battery, the main brain battery, where when you plug it into the charge, it flashes red, and this is because the battery is either gone faulty or doesn't have enough charge to charge the battery in the first place. So there is a video, and you can scan that QR code to get that video, and what that will do is it will show you how to kickstart the battery back to a state where it can be charged. And this works for 90% of the time. There are cases, and I have seen where doing this does not solve the issue, and the battery needs to be replaced. So just bear that in mind for the battery. Now I'm just going to cover some basics around the controller and also the brains. Some of you may have not done VEX in a couple of years. This could be your first time, so I just wanted to give some basics here, and then we'll go into some more detail around the programming. Okay. So over the years, VEX had loads of different programming languages and platforms and software to manage your code and manage your firmware and so on. And what VEX have started to do is standardize VEX OS firmware, or VEX firmware is now called VEX OS. So I think everyone's going down that route, which is the software that allows you to program the brain and all its components. If you have a Gen 2 robot, which most of you don't, but if you do, all this can be controlled from the one piece of software, which is VEX Code, okay, which is the programming language, programming software to allow you to program the brain and program the software, okay? Now, if you've got a Gen 1, which most of you have, you'll still need the VEX OS utility program. Some of you probably very familiar with that. And that's the piece of software that you would use to install or update your VEX OS across all your devices. And it's really important that the kids understand, or certainly the programmers understand, that all the VEX components and bits need to be at the latest version. And more importantly, all need to be on the same version. Because if you plug in a motor, let's just say a motor fails and you replace the motor, the first thing that should be done is that motor needs to be updated to the latest version. Otherwise, when you try and send code to the brain will actually fail. And in some instances, the brain will actually tell you your motor is the wrong version, please update it. And this is vitally important. So here's where you download it. And I'll just go through how to program the brain and also each component. So it's quite straightforward. What we normally do, what we ask folk to do, is plug all your devices, even before you build the robot. Now, if you build the robot, it's not a problem. If you've got any spare ports, plug in all your spare devices in as well. Make sure that all the spares are plugged in into the brain, including your controller, and turn your brain on while plugged into the computer. Okay, you'll have the software open. This is the VEX OS utility program, and once you do that, on the screen it will recognize which components are in need of an update, and they will actually show yellow. If they're at the latest version, then they'll show green. If the brain needs to be updated, it will also show yellow like this. Sometimes, and this is what I've seen too, is the brain needs to be updated first. These will all show yellow and sometimes show green actually, but the brain itself will show yellow. You update the brain, and I've seen it fail a couple of times, and then what the brain goes into is what's called recovery mode. All it needs to happen there is you unplug the brain, you plug it back in. Sometimes you need to remove the battery to do that, and it should then update. And eventually you'll see these flashing, and on the screen it will say installing VEXOS, and it will say that every time a component is being updated. When a specific component is being updated, you'll see it flashing green, okay, or sorry, flashing amber, and when it's updated, it will turn to green. Once everything is green, you're good. Everything is updated to the latest version. Every so often, VEX will release a brand new version of VEXOS, so it's advisable that that this is checked. And what you'll actually notice, and this is when the programmers are doing programming, that it will actually tell them within VEX code that the firmware is out of date. And if that happens, you're back to making sure all your spares are plugged in and get everything back updated, because it could be a single update to a motor or a sensor, or it could just be the overall VEXOS. So it's important to just keep that the kids keep that in mind as they're working through this. The last thing you want to happen is a component failing at an event. You replace the component, and then your robot doesn't work because it's the wrong version of the firmware. So just keeping all your spares up to date is really important. The other thing that, as these devices have been out in a box for such a long time, or if it's new, in order for the controller to communicate with the brain, they both need to be tethered. And the way you do that, and I've included a video here, the way you do that is you just connect them, you turn them on, and they should pair together. Okay, and on the next slide, I'll kind of go through this in a little bit more detail. In order to do that, there also needs to be radios installed on your brain and your controller. Avoid at all costs removing these if they're already installed. If they're already installed, leave them installed, and this process should work. Okay, the older and I left this picture on purpose because I wanted to show some people have these little radios and they're blue, and they should be blue. They're the smart radios. If you've got black ones, they're the older generation. They also still work. And in the back of the controller, and I can grab one here as well, you'll see a blue controller here. That's the radio on the controller. So once you have either a black or blue smart radio, they should be able to communicate using this method. Okay. Now, how you know it's tethered and connected, when you plug the cables in, you'll actually see this symbol. That means you're tethered. That's the symbol of a cable. And when you unplug the tether, you'll know that the controller is communicating with the brain, because it comes up like a little mobile phone signal symbol. And also there's a similar one that says link. I think some say link, some have the same symbols that will be on the controller as well. So that's how you know that you've connected successfully. Okay. Very good. So the next thing I want to cover is, now that we've got the brain talking to the controller, the robot is built, we need to start thinking about how do we program, not just for autonomous, but also how do we program our controller to best suit the robot. You can program this any way you like, and what I'll do is I'll give you some of my experience with this and how I would program it if I was to do it. But there are lots of options, as there always is when you're programming. The first thing we need to do is install the software, and I've talked a little bit about this already, that you're going to use to program the controller, and that's actually called VEX Code. back in the day, there were a lot of different programming languages. There wasn't really a standard, and this is the new standard for VEX. It's very simple. It's based on Scratch, so if the kids have done Scratch, they'll know they'll be able to get on with this really well, and it's really perfect for this type of use case. If they just think of the robot as a little, the little Scratch cat, they'll get on fine. So before I kind of go into kind of programming and so on, what I'll do is I'll go through kind of if you're completely new to Scratch, completely new to VEX Code, there's tons of help out there to get you started. Okay, within VEX Code itself, there are tons and tons of video tutorials for lots of different elements on how to set up your devices, to downloading and running the programs, to how to get started, how to drag the components in, how to remove them, how to replicate them, how to do lots of different pieces, right? So that's the video example. It's really simple instructions. And the next then are lots of example projects. So if you just didn't have a clue where to start, and the one thing you wanted to do was drive the robot forward, there's an example there. If you wanted to know how to use the bumper switch, there's examples there. If you wanted to know how to program the controller, there's examples there. There's even an empty template for Fling, which kind of gives you hints on how to program the controller for Fling. Okay. Then the other thing that's available is in context or inline help. So if you need help on any one of the items here, you can just click on it, and then there's a little help button. You click on that and it will tell you what that specific item does. Then there's other resources like VEX certification program, which you can take, which will also help you learn some of the basics. There's educator programs, there's free webinars, there's obviously the stuff we're doing here, and there's tons of stuff on YouTube as well to help. At its core, as I mentioned, VEX Code blocks is drag and drop, built on Scratch tree. It's very familiar to people. It's a free download, and I'd recommend. And I've seen kids saying, "Look, I'm not really interested in programming, but can I give it a go?" And they've gone and tried it. So I would say dive in, have a look at the examples to get going. Once you get familiar with this, then we have to start thinking about how do we connect the robot. How do I make my robot talk to code in a way that's meaningful? So the first thing that we need to tell VEX Code is what type of brain we have. So in our case, we're Gen 1. And also what are the different bits we've got connected for this robot. So we need to tell VEX Code what ports they're on. So this is where following the build instructions are helpful, because in the build instructions, it tells you, click the bumper to port 5, connect the catapult motor to port 4, the intake to 2, and so on. So if you follow that, then it'll be pretty straightforward if you use the template to make sure that you connect the devices or set up the devices to the right ports. That's the first thing. If you add additional sensors, that's okay too. Like I do have a gyroscope here. I have a touch sensor as well. If you have a vision or a color sensor, you can add those. And you just need to make note of what port they're plugged into in order to tell VEX Code which ports they are. And I would say also only configure them if they're connected to the brain. So again, I can upload a program with this actual device list here to this. But if, for example, I added a vision sensor here and I don't have a vision sensor connected to the brain, then there will be a problem. It will complain. Okay. Now, I mentioned before that the controller has to be programmed, and that's because we don't just have one kind of a claw, which is, if you look at previous robots before, we had a claw bot, which we had a claw that would open and close and maybe go up and down. This is slightly different in that we have an intake, we have this catapult, and we have a bumper. So we need to be able to program that. So I want to give you a head start as to how would you even go about that. Okay. In the brain itself, there is a driver control option, which doesn't actually work with the basic driver control function of the controller, and that's basically because the ports that I use are different. I don't know if VEX did that on purpose, but they did. So you do have to program the controller. Okay? So my recommendation is that you look at some example projects that get you driving, first of all. And I like to use tank control, but again, it's up to the children themselves. But tank control is where you move your left controller forward, and your left wheels move, and then forward. And if you move back, your left go back, and then this controls your right. That's what tank control will do. And then the other thing they need to think about is using the bumper switch. So this catapult, it has to go into a loading state in order to receive a ball. So in order to do that, it has to go down until it hits that bumper, and then wait until a ball is loaded. So we use that. We use code to basically say keep moving until you hit that bumper, and then stop, and then continue moving when another button is pressed, for example. So the way I programmed the controller in this instance was I press a button to load, and then once it's stopped, it stops doing anything, and then I press another button, and then it flings the ball. Okay. The other thing that would have to be programmed is some buttons to control this intake. And again, that can be controlled, keep turning until something happens, or turn it based on holding a button. So I have this one program that will just basically turn when I hold down the button, and then not turn. And then you also want to be able to turn it the opposite direction as well. So I'm using these two buttons here to turn either way. Okay. So in order to do that, we need to create a program and then store it into the robot as like an autonomous program. So it'll be in the brain. There's 4 slots, and for storing programs. So I normally store the controller into slot 1. Okay, that's just the default. You can store it wherever you want, and then call it controller or something like that. So that's the most important thing for them. And then for coding autonomous programs, you can store those in the other slots. Okay, and some things that can be done in the game. So I'm making the assumption here that everyone has watched the game video, which is probably what everyone should have done at this stage. But there are lots of things that can be done to score points in very short number of commands. So, for example, just turning the robot, driving forward, and hanging And now, actually, this robot does not have a hanging mechanism, but in Fling there is one. There's a hook, so you can just literally drive forward, turn left, go underneath the bar, and then close and then hang, and you're scoring points at that. I was in a competition, a scrimmage, and lots of people thought that you need to have one autonomous program to do loads of things at once to score points. That's not true. You can create 3 programs, for example, one to scoop all the balls out of this side, a second one to scoop all the balls out of here, and then maybe one last one to hang, for example. And you're allowed to, as long as you don't interfere with the balls in the arena, and if you do, they get omitted. You can do those in 3 separate programs and all run them in the 60 seconds. Okay, so just get the kids thinking about what can they do to maximize the points with the skill level they have with VEX code to see how many points. And like I said, to hang a robot, it's drive forward, turn left, drive forward, close arm, and there's a bit more involved in that, but it's, you know, you can effectively do that and score points. Okay, with any of this stuff, the next slide is probably one of the most important and gets overlooked so many times, and I've seen so many people get caught out, and that is, you know, when you're writing this precious code, saving it, backing it up is just so important. So I'm going to cover this a little bit here, and then, you know, if there's any questions, we can kind of cover that after. But you know, save your programs as you go. VEX code does not automatically save, so as you're going. So get the kids in the habit of saving as they go, and when they save it, it saves to the computer. That's the first thing. Okay. Then when you want to test the code, you can send it to one of the 4 available slots. Like I mentioned, slot 1 probably should be saved for the controller, but then select the slot that you want the program to go to and send it to the brain. If you select a slot that's already occupied on the brain, it will overwrite what's available on the brain already. So if that program on the brain is on slot 1 that you don't want to lose or haven't backed up somewhere, don't override it. Okay. Connect the brain. So this can be done with the cable, with the tether cable. I don't have it here handy. Which is the black USB cable. You connect that to the computer, to the brain. Same cable that you use to update the firmware. And once it's connected, this icon will go green, and then you click the download option, and that will download it to the brain. Okay. There are some wireless options, and this is only available for those who have the blue smart radios on the brain. So this is on the controller on the brain. You might see that. And this lets you connect, say, for example, an iPad directly to the brain, okay, to upload firmware. Seen it work successfully sometimes, seen it not work other times. But yeah, if you have an iPad, absolutely you can use those, or an iPad or a tablet, and you can send your code to the brain wirelessly without connecting the cable. Can be very handy if you want to make quick changes. I've included a video there to show you how that works. Okay. The last thing I'm going to mention, I'm touching this a small bit, is back up your code. So when you save the files to your computer, they go to I think it's the documents location. Back them up on a USB stick, email them to yourself, whatever it takes. And this is good practice as as our children are learning technology and so on, that we make sure we back up our stuff. The other option is, obviously, if you're backing up to a place that's on the cloud, fantastic. Those files will get backed up to the cloud. I mentioned this before, and I didn't mention it, but it's on the other slide, is if you're making major changes to code, make sure that if you're thinking, I don't want to lose what I did in the last version, you can use things like 001, 002, or some way, or even V1, V2, some way to know, so you can keep a track of the history of your files. If you are using cloud backups, sometimes they're included in those backups software. So that's the basics I wanted to kind of highlight for everyone. We'll include these slides in this communication. And I've added a few helpful links on this that I've kind of put throughout this deck to help. But if you have any questions, please reach out to us. I highly recommend anyone who's got some time to kind of look at the Educator certification course. Really, really useful. Look, there's a short exam at the end. It's free. But it really covers a lot of the things that I've talked about here, but in a little bit more detail. So yeah, look, have a great season. Look forward to seeing people, hopefully at scrimmages and events and so on. And stay safe. Speak to you soon.